now.
Hello and good afternoon and good evening in the other parts of the world. Welcome to Research Circle. Uh, I'm the host here, and today we are having our free webinar. Before we start, I would like to wish that all the in this pandemic situation, I guess all you are in the safe environment, and please, this is the message from us. Please take care of your near and dear, and please stay in your home. So our today's free webinar topic is green chemistry, that is microwave synthesis, and our today's expert speaker for this is Dr. Nilesh Pandya. Dr. Nilesh Pandya is an assistant professor, Department of Chemistry, UCA Tersadia University, Bardoli, Surat, Gujarat, from India. So, without wasting further time, I would like to invite Dr. Nilesh Pandya. Please continue.
Thank you, sir. I welcome all in this lecture. So we are going to start without delaying any further time. I just like to share the screen. Just a moment. I would like to say, sir, please just may allow me to share the screen.
Yes, you can do that now.
Is it visible, sir?
Yes, sir.
Okay, thank you. So, welcome you all. We are going to discuss microsynthesis. This is the topic of the green chemistry. Basically, what is the microsynthesis? First of all, we have to understand what's the microsynthesis. That the microwave assisted organ synthesis is the rapidly gaining acceptance by the valuable tools for the relieving some of the bottleneck in the drug discovery processes. Because what happens nowadays, whatever the synthesis, whatever the new drug synthesis or whatever the new compounds that we are going to synthesize in laboratory, there are by the conventional process and it will take lots of time. Some of the processes are taking too much time, 12 hours, 20 hours. So to reduce the time period and reduce the manpower, we can carry out such type of reactions in the microwave. So it will reduce the times as well as the manpower. So basically, the microwave assisted synthesis are the backbone nowadays in the drug discovery. The basic principle behind the technology are greatly used to summarize recent trends and the area in the drug discoveries, where the microwave technology has made an impact. Just a moment, I would like to share the slide. So, what is the basic green chemistry in microwave induced organic reactions? What it affects? First, it is the rapid reactions rate. This is very much important. The cleaner the reaction conditions and enhancement in the chemical yields. So basically what happens in the combinational chemistry, which today's what are more often than that implies parallel synthesis has become an integrated part of the drug discovery, helping companies to reach their goals. However, increasing throughout by the speeding up the chemistry itself. This line is very important. That whatever we are synthesizing in an industry, in a laboratory, but that particular reaction, that particular research should be speeding up. In the conjunctions of the automations and the computer control has been recently introduced to the drug discovery process. All of you are familiar with that. But the QSAR and SAR, which are we are implementing in our drug discovery nowadays, understood please, has been recently introduced to the cleaning drug discovery processes by the microwave dielectric heating. The short reaction time and expanded the reaction range. This line is very, very important, please. It will also expand the reaction range that is offered by the microwave assisted organic reactions are well suited to meet the increased demand in the industries nowadays. Understood? Now, what happens in the microwave reactions? So here this is a comparison between the conventional heating and the microwave heating. Here you can see that in the conventional heating, what happens that the reactions is taken in the sample and the solvent, whatever the reaction that we are carrying out, we are using any such kind of solvents or a medium in that. In the conventional heatings, what happens? We are giving the heat from the outside. So the temperature on the outside surface is excess of the boiling point of the solvents. So compared to that, in the microwave, what happens? The sample solvent mixture absorbs the microwave energy and localizing superheating. So vessel wall, what happens? It's transparent to the microwave energy. So in the microwave heating, what happens? Please, basically, most of the organic reactions require heat have been heating using the traditional heat transfer equipment such as oil bath, sand bath, or a heating mantle. Normally, what we are doing in the general laboratory practice, what we are doing such type of conventional reaction either by using wire gas, either by using oil bath or sand bath or a heating mantles, but they are the conventional process. In the microwave heating, what we are doing exactly, we are passing the microwave from the reaction mixture. Basically, whatever the solvent which are using in this particular reaction for a particular organic chemical synthesis, all are basically polar solvents. What why we are using the polar solvents that we will discuss in the upcoming slides. But these techniques are rather slow and created a temperature gradient. which we are talking about, we are talking about the conventional technique within the sample. In contrast, when we are using the microwave dielectric heating, the energy is introduced into the chemical reactor remotely, and there is a no direct contact between the heating and the solution, between the energy source and the reaction mixture. Please keep this thing in your mind. This is the basic points of the microwave assisted organic reactions. Like you see in the image, the microwave radiation passes through the walls of the vessel and heat the contains directly by the taking advantage of the ability of the some liquids and solid to transfer the electromagnetic radiation into heat. Understood, please? Now, this is the video, but I thought it is not playable in the Zoom. Basically, what happens in this when you put any solvents in the reactions, basically in the microwave, what happens? Basically, suppose if you took the water as a solvent, the general boiling point of the water is 100 degrees Celsius. But in the when you put 50 ml of the water in the microwave for the only 1 minute, it is going to be boiled at 81 degrees. Understood? In the similar manner, if you put at 1 minute for the methanol, so immediately after 1 minute, its temperature is going to be 65 and its boiling point is near about 65. So basically, I hope it is going to be playable, but it's not. Never mind. Now, what is the basic microwave reaction that we have to understand? That what happens in the microwave reactions. Basically, when you put any such kind of solvents in the microwave, what kind of effect, what kind of mode of actions it is occurs on that particular microwave. So basically, microwave is the collective terms of the electromagnetic radiations with the frequency in range of 0.3 to 300 gigahertz. This is very, very important. Here, the microwave irradiations, just a moment. The microwave irradiation was passed near about the range of the 0.3 to 300 gigahertz. The most of the frequency in these bands are dedicated to use the radar equipment and also in the telecommunications. Like example, if you talk about the dual band mobile, understood, please. It's operate at 0.9 and 1.8 gigahertz. Understood, please. So to avoid this interference between the different applications, it has been agreed that the appliances of the heating purpose will operate at 2.45 gigahertz to corresponding a wavelength of 12.2 centimeters. Understood, please? Just a moment, I would like to change the slide. Okay, so this is the comparison between the X-ray, UV, visible, microwave radiation and their parameters. Now, sorry, absorptions of the microwave energy occurs by the two mechanisms. The very first one is the dipole rotations and second is the ionic conductions. Now, first of all, we have to understand what the dipole rotations occurs in the microwave electrical field interactions with the water molecules. Here, what happens? The energy in the form of microwave can be transferred to the substances that are present in the beam line of the microwave radiations. Understood, please? So the absorptions of the energy occurs when the dipole moment rotates the elements themselves with the fluctuating electric field. Understood, please? So the component of the irradiations or when ion moves back and the force by the same phenomenon. Understood, please? So this is the ionic conductions in which what happens the microwave radiations with the calcium carbonate. So such type of reactions, what happens? In it, the ability of the substances in the heat microwave fluids is depend upon the two factors. Basically, what happens? First, efficiency with the substance absorb the microwave energy, normally described by its dielectric properties. Understood? Please keep this thing in your mind. There is what very first point is that the efficiency in which the substance absorbs and the micro energy normally described by its dielectric properties. And the another one is the efficiency which the absorbed energy can be converted into heat, described by this loss factor that we will discuss here. Now, please, why the micro-assistant organic synthesis is required? Basically, first, it is a slower, short reaction times. Just a moment, I'm having some technical issues. Okay, why micro-assisted organic synthesis is required? A short reaction time, easy workup procedure, reaction may be carried out in the presence of solvent. The solvent-free techniques is also facilitated. Easy of the synthesis of the laboratories of the compounds, the availability of the commercial micro equipment intents for the organic chemistry. Now, the demand of the micro-assisted organic synthesis, the very first one, the short reaction time. This is very, very important. An expanded reaction range that offers by the micro-assisted organic synthesis are suited to the in, increased demand in the industries. In the particular, there is a requirement in the pharmaceutical industries for the bigger number of the novel chemical entities to produce, which requires chemists to envelop a number of resources to reduce the time for the synthesis of the compounds. Understood? The development in the synthetic chemistry have generally been concerned with the novel and highly reactive agents in the solutions on the solid support. Now, what does it do? The chemical reaction required to supply the heat energy. For any such kind of chemical reactions, you have to pass the energy in form of heat by the heating metal or by the any other sources. You have to provide the heat for the chemical reactions. This is generally achieved by using the traditional heat transfer equipment such as oil baths, sand baths, or heating jackets or heating mantles. These are generally slow and consume large excess of the energy than required. This line is very important. That's why we are using that way we are adopting right now the microsynthesis. What happens generally in the normal conventional processes? It takes lots of time, lots of heat, and lots of manpower. Understood? So, in addition to local overheating may occurs the causing decomposition of the degrades or products. The micro irradiation is the targeted only the heat the sample depending on the dielectric behaviors. It is easy to control the energy supply to the sample by adjusting the power of the radiation, basically. Now, how does it work? The microwave radiation passes through the walls of the vessel and the heat only the reactant and the solvent, not the reaction vessel itself. This line is very, very important. Understood? So the total heat, total the radiation which is going to be applied on the synthesis is only applied on the reactant and the solvent, not the reaction vessel itself. Understood? So if the apparatus is properly designed for the convection, the temperature increase will be uniform throughout the sample, which can lead the less byproducts and or decomposition products. This line is very, very important. Keep this thing in your mind as a chemist. What's our, just a moment. As a chemist, what is the main goal of our any chemical reactions? That we have to maintain the reaction conditions and we have to reduce the byproducts, the amount of the byproducts and the hazardous products which are obtained at the end of the synthesis. So at that At that point of view, the microwave assisted organic synthesis are very, very useful. Understood, please? Just a moment. I would like to change the slide, but it's not happening. Okay. Now, how are the reactions are carried out? The reactions are carried out generally in two types of reactor, basically commercially available microwave synthesizer, and domestic microwave oven. In general, all the reactions are carried out in the vessel made of the glass. Now, what are the advantages and the disadvantages of the microwave synthesizers? The very first one is the control of the total reactions. Maintenance of the temperature can be combined with the pressure technique also. And what are the disadvantages? Basically, first of all, you have to purchase the microwave. It's expensive. Some features are reduced. Now, what are the domestic microwave ovens? What are the advantages of the domestic microwave ovens? The most features are available. There is some control to not to extend for the synthesizer, and it's inexpensive. What are the disadvantages? Lack of complete control may lead to runaway reactions and decompositions. Not equipped for the reaction that occurs in the steel tube and other pressures conditions. Now, what are the advantages and disadvantages if you are going to compare the domestic and the modified microwave oven? What are the advantages? The most features are available. The recent oven have some control devices and inexpensive. What are the disadvantages? The lack of the complete control may lead to the runaway reactions and decompositions. The reaction that occurs in the seal tubes and other pressure conditions are not possible. So these are the basic disadvantages and advantages of the comparison of the domestic and modified microwave ovens. Now, what are the experimental methods for the microwave synthesis? The most reactions are reported in the literatures are carried out in the microwave oven by one any one of the following methods. The very first one is the reaction carried out in the open vessel using the solvent at high dielectric constant. Second one is the reaction carried out in the sealed tube. And the third one is the reaction in the dry solventless conditions. So this is the basic three procedures in which we can carry out microwave synthesis. Now, what type of reactions are carried out in the microwave reaction? The very first one, reaction that are conventionally run out by thermal processes. You can you cannot do it without any heating. The reactions like protection, deprotection, condensation, oxidation, reduction, rearrangement reaction, Diels-Alder reaction have been extensively studied using the microwave oven. Understood? So the recent developments are dedicated to use the microwave radiations in the dry conditions also. So these are the two examples of the microwave ovens. Basically, these are the modified microwave ovens. And this is the Q-Pro modified microwave oven, in which you can also maintain the temperature, pressure, and the voltage of the particular organic reactions. And this is the microwave which we have also used. This is the internal part of the microwave. This is the rod in which we are putting in the flat bottom flask, in which we can pass the microwave. Now, we are going to discuss some of the microwave reactions. But before that, first of all, we have to understand for the any chemical reactions, he requires some kind of solvent, he requires some kind of phase carried out organic reactions. But the solvent plays a very important role in any chemical reactions. Now, in case of microwave assisted organic synthesis, what are the role of the solvent? That any solvent have high dielectric constant and high BP is the excellent transfer medium for the variety of the microwave introduced organic reactions. In simple words, the polar solvents are excellent solvents medium for the microwave reactions. Understood, please? Why? Because the polar solvents such as like DMF, if you talk about DMF, NMP, ethanol, etc., which are polar solvents, are a good microwave absorbers and will heat efficiently. That's why we are using the polar solvents. Mind well. On the other hand, the less polar or a non-polar solvents, like if you talk about toluene, dioxide, etc., are the transparent to microwave irradiations. That's why we are not using such kind of solvents for the chemical reactions. Understood, please? I'm repeating it again. The choose of the solvent is very, very important in the microwave reactions. Basically, we are using the polar solvents in the all type of organic reactions in the microwave radiations. Why we are using it? Because what happens when you choose any solvents which is having a high dielectric constant and higher boiling point? Basically, it is an excellent transfer medium for the variety of the microwave induced organic reactions. Basically, this type of polar solvents, such like DMF or NMP, if you talk about ethanol, all this type of solvents are very good microwave observers. What happens? Because they are very good microwave absorbers, they will heat very efficiently. And if you talk about the non-polar solvents like toluene, dioxide, and all other solvents, so these solvents are basically transparent to the microwave irradiation. Understood? They are basically not they are transparent to microwave irradiation. They will not heat in the pure form. Understood, please? So now, if we talk about the ionic liquids, in some of the organic reaction, we are also using the ionic liquids. So in the ionic liquids are the fluid salts. In both, they consist entire forms of ions. Absorb the microwave radiations in the highly efficient manner. Understood, please? So what happens? It will absorb the microwave irradiations. So this type of fluid solids or the ionic liquids are also very good solvents for the microwave irradiation organic synthesis. Understood, please? Now, if you talk about some of the solvents like water, so temperature of the 50 ml of the water after heating for 1 minute in the microwave at 50 degree volt, what happens? Its temperature rises up to 81. For methanol, it rises up to 65. For ethanol, it rises up to 78. If you talk about acetic acid, if you put it for 1 minute in the microwave, the temperature will rise up to 110 degree. If we talk about ethyl acetate, the temperature will rise up to 73 degree. If we talk about chloroform, the temperature will rise up to 49 degree. Understood? So these are the comparisons, some of the solvents. Okay. So now we are going to first discuss the reactions, the oxidation, the methyl group, and the other side chains of the aromatic compounds oxidized by the chromate to give the corresponding preparing the aromatic carboxylic acid and also aid in the identifications of the aromatic hydrocarbon and their derivatives, since the acids are the crystalline solid that can be purified and crystallized easily. The oxidations of the toluene into benzoic acid, para-nitrotoluene into para-nitrobenzoic acid, para-chlorotoluene into orthochlorobenzoic acid, anthracene through anthraquinone, that have been compared with the conventional procedures. So this is the example okay. I hope all of you are able to see this now. Okay. So in this reactions, you can see that it's the oxidation reaction which is carried out in the microwave. Here the comparison, you can see that both same kind of reaction is carried out in the both the ways, by the conventional method, while in the microwave methods. Well, the conventional method, the time required for this reaction is near about 30 minutes. While the same kind of reaction that can carried out in the microwave, it required only 5 minutes. Understood? And here you can see the comparison of the yield also. So via microwave method, the percentage of the yield is also increases. Mind well. Understood, please? So the same reaction was carried out by the conventional method as well as the microwave method. The comparison status is here given below. Here, what happens? This is the procedure: a mixture of the toluene and sodium dichromate in 50 ml of the water and 0.2 potassium hydroxide solution was taken in the 150 ml enzymal flask fitted with the funnels at the loose top. It was irradiated with the microwave for the 5 minutes. After cooling, the reaction mixture was extracted with the ether to remove the unreacted toluene. The aqueous layer was acidified with the H2SO4 solutions and then it was extracted with the ether. The extract was dry and crystalline compound was isolated by evaporation of ether. Understood? So such kind of reactions, we can complete it within a 5 minutes with the higher percentage of yield. Understood, please? Just a moment, I would like to change the slide. Okay, there is one another example of the oxidation of the toluene. We can produce this anthraquinone from the anthracene. Here, the same reaction was carried out by the conventional method as well as from the microwave method. And the comparison here you can see in this table. What happens when you carried out such kind of reaction via conventional method by normal heating? It requires 60 minutes, while in microwave it hardly requires 8 minutes. Understood? And if you are going to compare the percentage of the yield is also in microwave, you will get higher amount of yield. Understood? So this is the comparison of the oxidation reactions. Here, you can see that by a conventional method, the time required for the reactions, and via the microwave method, the time reactions require in minutes. So here you can see that if you are going to compare such this third reaction, this reaction require 180 minutes. Means near about 3 and 3.5 hours. And in microwave, such kind of reaction completed within 10 minutes. Understood? And the percentage here you can see the comparison of the yield, the percentage of the yield. Okay, so by the microwave method, you can complete such kind of reactions within a short period of time, by the reducing manpower and time periods. Understood? So that it is clear to form a data in the table that the yield of the products is various oxidation reaction increased to the reasonable extremes only, but the reaction time was reduced appreciably. The clear reflects that the unity of the micro method over the conventional methods. Now, another method is the esterification method. That the esterification reactions of the benzoic acid with the methanol, ethanol, propanol, and the butanol esterifications of the salicylic acids and the cinnamic acid with the methanol were carried out by more techniques, and the result and the comparison compared with the conventional procedures. It was observed that the microwave dramatically reduced the reaction times and significantly increased the yields of the products. Here one example is given in which we are producing the methyl benzoate from the benzoic acid. So see here in the reactions is carried out via both the methods, by conventional method as well as via microwave methods. So here you can see the comparison status of both these methods. In the conventional method, you require 360 minutes. Mind well, it's required 360 minutes to complete the whole reactions. While in microwave, it's hardly require 5 minutes. See, here is the comparison of both the reactions, same reactions. Here you can complete it within a 5 minutes with the better percentage of yield. Understood, please? We are not going to go through this processes. Now, another one is the esterifications of the benzoic acid with the ethanol. So, same reaction was carried out by the conventional method as well as by the microwave method. And see here the comparison of both the things. Here, the ethyl benzoate is produced via conventional method. It required 240 minutes to complete the reaction. Understood? While in microwave, you can complete the reaction within a 5 minutes. And here you can see the percentage of the yield. In microwave, you will get the higher amount of yield. So here is the comparison of the esterification reactions. Here you can see that when you complete the benzoic acid and methanol, benzoic acid and ethanol, propanol and butanol, etc., etc. And here you can see the comparison between the microwave methods and the conventional methods. Here, in this in this step, the benzoic acid and propanol. Here, the reaction time required for this reaction is 450 minutes, please. And in the same things, in the microwave, hardly require 20 minutes. Understood? So see here the comparison between these two things. So it reduces the time for the reaction, accelerate the time and reactions, and you will get a higher amount of product, 74.6% of the yield. And if you are carried out such kind of reaction with the conventional method, you will get 68.1% of the yield. Understood? So it is clear from the data that the table in that yields of the products is various esterification reaction increases to the reasonable extremes only, but the reaction time was reduced appreciably. This clearly reflects that the utility of the microwave methods over the conventional methods. And this is also comparison one more time. Now, Benzoylation reactions is the substitutions of the hydrogen atoms of the hydroxyl groups of an amino by the benzoyl group. It is known as the benzoylation reaction. It may be achieved by using the benzoyl chloride. It is not possible to carry out the benzoylation reaction using the benzoic acid, but in the presence of microwave, benzoic acid can be used for the benzoylation. This is very, very important. So in the present work, it's proposed to use the benzoic acid for the benzoylation of the formic acid and the substituted phenols. Here you can see in the reactions, So what happens in this reaction? Basically, formic acid and the benzoic acid were taken in the aluminum flask, filled with the funnels as a loose top. It was subjected to microwave irradiation at 40% power in the microwave oven for the 1 minute only. After the completion of the reaction, as monitored by TLC, the contents were poured into the crushed ice. It was then stirred for the 15 minutes and filtered. The solid product was transferred into aqueous sodium bicarbonate solutions to remove the unreacted benzoic acid. Then the solution was filtered and the solid residue was washed with the water. The product was recrystallized from the acetone and crystallized by IR, 1H-NMR, and elemental analysis. Understood, please? This is again benzoylation reactions of the some substituted phenols are there. Now here the comparison in the solvent-free reactions. First, formic acid is converted into benzoyl formic acid. The reaction required time is 1 minute in the microwave and percentage. See here that this table is shown that the percentage of the yield is very high compared to conventional method. Understood? And this whole reaction is carried out within a very short time periods. Understood? So it is clear from the observation that one can successfully carry out the benzoylation reaction using the benzoic acid in the microwave oven. The yield is good and even the reaction times are quite short. They clearly show that microwave methods is suitable method for the benzoylation. Understood? So these are the some other more examples are given. So we had discussed this thing, esterifications and benzoylations. Just a moment. Okay. Now there are some other reactions are there. The tracking the rate enhancement. So here what happens? By conventional method, you have to carry out such kind of reactions at a 100 degrees Celsius temperature for 72 hours. And when understood via microwave reactions, you will get 100% of conversation. So this is very important. Basically, if you're going to carry out such kind of reactions, so for this reactions at 100 degrees Celsius temperature, at the end of the reaction, you will get 70% of the products. While in microwave, you will get near about 100% of the conversations within a 10 minutes. One more comparison is that such kind of reactions, when this is a basically aqueous phase reaction, so it's a totally green chemistry reaction. Basically, when you carried out such kind of reactions in aqueous phase for the 48 hours via conventional method, while the same kind of reaction is carried out in the microwave, you will get 70% of the conversations within a 10 minutes. So one more example, this in a conventional method, it's required near about 48 hours and the percentage is of the yield is near about 25 to 50%. While in the microwave methods, you will get 10, 30 or 30 minutes for the different solute or solvent. Understood, please? One more example is given here that the conventional method for this particular reactions, you have to reflux it for the overnight means 12 to 14 hours is required to complete the reactions. Understood? While in microwave, such kind of reaction is carried out within a 5 minutes. Understood? So this is the biggest advantage of the microwave reactions. One more example is given here. While this reactions is carried out at for the 48 hours, mind well. While in such same kind of reaction is carried out in the microwave for the only 8 minutes. Understood? Now, one more examples for some kind of such kind of reactions. It's the solvent-free reactions. Here, in this method, 52% yield after heating on the in the methoxy ethanol. And such kind of reaction is carried out in the microwave for only 5 minutes. Uh, so one more multi-step reactions. This reaction is basically a multi-step reaction when you carried out at a conventional procedure. While in microwave, you have to carry it out for only 5 minutes. Another step is required only 5 minutes, and the third step is required only 5 minutes. Understood? So the three steps, one vial and one purification. This is the speciality of the microwave reaction. Same another multi-step reactions. Here you can see that the conventional method you have to do it in the overnight, while in the microwave reaction, such kind of reactions is only carried out within a 10 minutes. One more examples for the reactions. Here the reaction is carried out only for 2 to 3 minutes. There are some more examples of the reactions. This is the alkylation reactions. Basically, alkylation reactions carried out in the conventional methods, base solvent reactions, and this reaction is carried out for 10 to 12 hours, while in microwave it requires only 5 minutes, and it's a clean conversion. So these are the microwave, another examples of the microwave assisted synthesis via aldol and noalgel condensation reactions. So these are the name reaction in which will get a higher amount of yield at the end of the reactions via microwave irradiations. Another examples is the microwave assisted synthesis for formaldehyde derivatives via aldol and noalgel condensations. These are the cyclization reactions. Synthesis of quinoline derivatives. This can be also carried out by using the microwave reaction, microirradiations. See here one comparison is shown in this table. So here you can see that at conventional heating it requires 2 hours, microwave only 2 minutes. It yields 72%. By microwave it will yield 88%. So this is the beauty of the microwave assisted organic synthesis. These are the oxidation reaction that we had discussed. These are also a comparison between the microwave assisted organic synthesis and the conventional synthesis. These are also one named reagent. Synthesis of substituted 3-formyl benzolate. These are also reported process. See here, this is very important. Synthesis of 4-alkyl 1,3-diaryl pyrazole. This derivative, such kind of reactions can be also carried out by using microwave irradiations. In a conventional method, you will only get 40 to 50% of the product, while in microwave method, you will easily get more than 78% yield. This is the synthesis of 1-pyrazole 4-carboxylic acid esters. These are also one comparison of the microwave assisted Waldenburg crystallization of 2-azido-acetophenols obtained from the 2-bromo-acetophenol leads to the formation of oxazole carboxyaldehydes. So this is the mechanism of the previous reactions. Same this kind of reactions that the chloroquinoline were obtained by the cyclization of orthoazidochalcones under the microwave irradiation. Is the comparison. So this is very important. Here you can see that the 3-component complete reaction can be also carried out in the microwave irradiations. Understood? These are one more examples of the 3-component coupling reactions. Another examples of the three-component coupling reactions. Basically, three-component coupling reactions are difficult by the conventional methods. So in methods, you can easily carry out such kind of reaction within a 10 to 12 minutes. Another examples of the synthesis of the novel 3,4-dihydropyrimidinone on the water-soluble solid support catalyzed by the Indian reflex. This is another examples of the three-component coupling of the reactions. The synthesis is the table percentage of the yield and the time required in the microwave irradiations. One more example is given, the deep protection reaction. So the deep protection reaction is also carried out in the microwave irradiations. So these are some examples which are given here. And this is the table in which you can see the comparison, and the time required for the microwave reaction is hardly 1 or 2 minutes, and the percentage of the yield is near about 90. One more, cycloaddition reactions is also multi-component reactions. Now, basically, this is the last slide. What I want to discuss that why does microwaves speeding up the chemical reaction? We have discussed all these kind of reactions that we have discussed, esterification, we have discussed the oxidations, but basically the chemical reactions performed using the micro-associated organic synthesis techniques are rapidly mainly because the reactions are performed at a higher temperature. Then there are conventional counterparts. This is very important. You know that the modern microwave-based synthesizer can achieve a temperature up to 250 degrees Celsius and pressure up to 20 bars. So the microwave effect is reasonably for the observe the rate acceleration. Understood? So that's why we are using the microwave reactions for such kind of organic synthesis, and nowadays it's very important. Okay, thank you all to listening me from my side. Now I'd like to hand over to the research circle person to complete the session. Thank you.
Yeah, thank you so much, sir. I will we'll do we don't have any question answer session, so we'll try to provide the email ID of Dr. Nilesh so that you can ask your questions or any help relating to your research to their email ID directly. Okay. So before we conclude, I would like to thank all the participants who have joined us through Research Circle app via YouTube Live and Facebook Live as well for their patience. And again, I would like to request all of you to please stay in your home, be safe, take care of your near and dear, and just spread knowledge, not the virus. And we are running this series of webinars. We do have many webinars available on our Research Circle YouTube channel. This particular webinar also will be available on our Research Circle YouTube channel. If you want to watch it again or if you want to share to your colleagues or friends, you can do that. So at last, I would like to thank Dr. Nilesh Pandey for taking out time for us and delivering this knowledgeable webinar for all the participants. So with the due permission of today's expert, I would like to conclude this session and I would like to end the meeting here. Thank you.
Thank you. Thank